I am James Strassburg. I'm a senior software architect with a company called Direct Supply in Milwaukee. And I've recently done a lot of work bringing continuous delivery to our search engineering teams. As part of this talk, I'm going to be talking about 3 different GitHub repositories that I have. And there's a shortcut to a gist that I've put together if you want to go check them out. That will link you right to a gist that links you to each of the 3 independent repositories, and each one has their own README and instructions so you can follow along. Maybe not today, but later. I'll put this up again at the end of the talk. So objectives for this talk. I want to start with a brief overview of continuous delivery in case anyone hasn't heard of it. This is something that software engineering teams have been doing a lot of, and I don't see as much of that in the infrastructure and more, I guess I would kind of put search engineering kind of in the middle. But I want to bring some of these techniques that are evolving in the software engineering world into our search engineering group. I'm going to talk about implementing a delivery pipeline using Jenkins as code. And by having our pipeline defined as code, we get to version control it. As part of this, I've separated the build and deploy of Solr itself with the deployment of our Solr configuration. So I'm going to have a bit on packaging and deploying Solr with a pipeline. And separately, there'll be a pipeline for the Solr configuration, which exists in its own repository. So real quick, where we're going, this is a screenshot from Jenkins, and this is the kind of what the simple pipeline that I've put together looks like when you run it. This is for deploying Solr itself, and here's one for deploying the Solr configuration. With most things, whatever pipeline you design is going to look very different because you could have branches and other types of integration tests, manual approval steps. But this is a simple pipeline that I put together, which I'll show you later. We're going to deploy a configuration to a stage environment, run a test, deploy to production, run a test. So does anybody here have some experience with continuous delivery? Somewhat? All right. Just wanted to give a brief overview for some of you that have not. The ideas behind continuous delivery are that your deployments become predictable and routine. What they say about things that are hard to do is you do them often. And by making things predictable and routine, you have to do it all the time. You have to get good at it. Delivery differs from continuous deployment in that every change is deployable. With continuous delivery, you're not necessarily going to deploy it because you may have business constraints that prevent you from, once a change is committed, immediately rolling that into production. You might have to wait for a certain time or a certain day or a manual approval step. But by focusing on the fact that every change is deployable, you still have to build the same controls and error proofing that you would have to build if you were going to go right directly into production. A big idea as part of this comes out of lean manufacturing, which is that you want to reduce work in progress. If you've got code changes that are sitting, that aren't deployed to customers and that aren't ready to go out, that's a form of waste. The manufacturing equivalent of that is having a lot of inventory that's not getting used and sitting on your shelf. You've potentially already paid for that, it's taking up space in your warehouse, and you're not getting any business value out of it because you haven't sold that or moved it. Same thing with code, or in this case, any Solr or search development work that's gone on. You're not getting the benefit of that until your users have access to it. And does anybody here know how to pronounce that? Because the 30 seconds of YouTube research I did was inconclusive, but it's something like poka-yoke or poka-yoke, but it's a Japanese term for mistake proofing. And this is the idea that we're building in checks and balances into our deployment pipelines so that it makes it difficult to insert a mistake by a search engineer. So some examples of that would be in a manufacturing process. If somebody was going to install a pane of glass, you'd make it very obvious that they installed it backwards or upside down. Or another great example that I like is how you can only plug in a USB jack correctly on the 3rd try. I also wanted to include a joke about a lesser-known Pokemon, but I didn't know enough about Pokemon to do that. So I just put one that my kids would like when they asked what I was doing. So at my company, we've got Jenkins 1.something deployed, and the stuff I'm going to talk about today is from the 2.0 plus version of Jenkins. But I first did the work on Jenkins 1, and you can do all the same things that you can do with the 2.0 pipeline as code, but there's some disadvantages to it. And after my talk got submitted, 2.0 was announced within, I think, 5 days of me getting my acceptance. So I got to redo all the stuff. But prior to 2.0 version, pipelines were implemented with plugins. And the two plugins that would be of interest are the build pipeline plugin and the copy artifacts plugin. Those are two that I utilized in order to develop it. But when the announcement came, I had to make a decision. And I'd recognized some disadvantages with the old plugin process, which was that each stage of your build required a separate, or each stage of your build pipeline required a separate build, and you had to wire them together in the properties of the build. And it was kind of complicated in order to keep track of how everything was connected together. Since it's all configured right in Jenkins, the pipeline was not version controlled, so if you make changes, you could potentially break the entire pipeline. And like I said, it complicated the build configuration, and it just meant more work for me because I wanted to do the new thing. So I re-implemented everything I had done at work for this talk specifically in Jenkins 2.0. So what do we have now in Jenkins is the idea of pipelines as code. And what you get is in your repository, you can create a Jenkins file, and the Jenkins file defines your entire pipeline. It can be version controlled in your repository, but it's a Groovy script. And the idea here is that it's similar if you've worked with Docker or Vagrant. There's a Vagrant file. Docker has a Docker file. Travis CI has a travis.yaml file. I know they use the YML because it's YAML, but it's the same idea. You have a configuration file that's defining something you're going to do that you can put in version control. Another corollary to this that I'm really interested in looking at a lot is GitLab, which is a competitor to GitHub, has a GitLab CI functionality that's been released fairly recently. And that looks like you could do a lot of the same stuff as this, but I think it has a little bit more, a little bit easier use case in that with what we're doing here, the builds and the parts of the pipeline run on the Jenkins server as a whole. The GitLab CI implementation lets you choose a Docker image to run all of your pipeline steps in. So you could pick, like, for when we're building Solr, I have to have Java JDK on the Jenkins server or the build agent. With GitLab, I would just say, give me a Docker base image that has JDK 8 on it, and everything runs isolated from the whole Docker or Jenkins server. So I had no experience with Groovy when I started doing this, but this is a very, very simple example of what a Jenkins file looks like. You first have a block with a node, and it doesn't look like it's doing much, except that if you have multiple build agents, you can pass a parameter to that saying, give me a Linux node or give me a Windows node, and it will run that block of stuff on that agent. So the stages in the pipeline are just a stage statement. And you notice in this example, I have a build, test, and deploy. And there's a bunch of things you can do in each of those stages. You can have multiple statements under each one. In this example, I'm just running a shell script, and I'm doing that in my example implementation as well. But this is just echoing out building, running tests, deploying. And this alone would get you those 3 boxes that you saw earlier with the pipeline defined. So with the example implementation that I have the link to, I have 3 repositories. I have a fork of the official Lucene Solr repository, and I'm working in, I think, the 6.1 branch for this work. I have a repo for the Solr configuration. So after we've built and deployed Solr as a package, I have a separate repo that is what the development teams would work on in order to define config sets with schema and whatever other configuration we want to pass down to the server. And a third in the main repository is a repository with configurations for running Jenkins on your own machine. And what this will do is there's a start script in there, and when you start it, I think that's the next slide. When you run the start script, it does a vagrant up, which starts up 2 Solr servers that are just base Ubuntu images on your machine. One's called stage, one's called prod, and then it runs Jenkins as a Docker image with everything coming out right to the console, so that when you hit Control-C, it'll stop that Docker image and then does a vagrant down or stop or whatever it is to kill the two Solr nodes. And what I have in this repository is also the Jenkins home directory, so all the builds that I'll show you in a bit. When you start it up, you'll see the builds that I've used for the example, and you can go in and look at how they're configured, and then the repositories have the scripts. And after you start it, you just browse onto your machine localhost 8080 and log in as admin, and you'll be in Jenkins running on your machine. There'll be builds defined that can target those two Solr nodes that are running on your box. So somebody, I thought, might ask, why build and package Solr myself instead of just downloading the official package? And I started using Solr with version 3.6.1, I believe. And right before I released 4.0 went to market. Because of that, we're still running with a master-slave replication configuration instead of Solr Cloud, and that bothers me to this day that we haven't prioritized the work to flip that yet. But shortly after that, we upgraded to 4.3 and then 4.8.1. And in between those upgrades, we encountered bugs that were fixed with JIRAs that we wanted, but we had to do a lot of work to make sure we regression tested our applications that were running against Solr so that we didn't encounter any type of breaking change. And the idea behind building it myself was that if a very simple JIRA patch was released for a bug that I wanted fixed, but I didn't have the bandwidth in order to do a full regression test, or if I didn't want to wait for an official release to come out, then I could just choose to apply that JIRA to my own fork, build it, package it, deploy it, effectively the same version with a non-breaking change and simply a bug fix. Also, I think forcing yourself to build Solr helps you start to get an understanding of the code base. If you haven't actually dug into the code, you should, because if you can read the code itself is in my opinion, the best and most accurate source of documentation. And I've often found myself seeing something that was missing in the official ref guide and then going to dig it out of the source code itself. But like with all things, if you don't want to build it yourself, you don't have to. You can just grab the official package as part of your pipeline and deploy it. So the Jenkins file that does the Solr build looks like this. And the important things to note are that I have a stage called build Solr package. That second line is locating the ant tool that's installed with Jenkins and getting its path on the path. Checkout SCM is, since I have a Git repository configured in the build, is doing a Git clone of that repository into the workspace of the Jenkins build. So at that point, it's actually cloning the Lucene Solr branch that I specify into the workspace. And then we have two ant commands. The first is IV bootstrap, which is one that you have to run before you build Solr. And the second one is the actual ant create package command. Or the create package target is the thing that will build Solr and create the tarball like you would if you were downloading it from the official package repository. One thing that I want to call out is setting the version.suffix to the build number lets me track my specific builds against whatever version of Solr I'm building. And how this is going to manifest is when we see it on the site, we're going to have a dash build number on the end of the official 6.1.0 that I'm using. And by having that on the end, I know that if I've applied something, that I can track back to where it came from. And then the last step is to just archive the artifacts so that we've run a build, we have a new tarball, we want to archive that on our build server so that we could refer back to it if we needed to. Deploying Solr then is using I have a shell script. This could also be done with something like Chef or Puppet, which may be preferable in many cases, but I was trying to minimize the number of things I had included in this example. So I wrote a shell script, which you can look at it, but it effectively just makes sure Java is on the target machine. In this case, when you vagrant up that stage Solr node, it comes up on your machine as 10.0.0.11. And you can pass some parameters like what you want the service to be called, what the home directory is going to be, what port, and then a private key to use by that script to talk to that target server. And inside, when it's actually doing the deployment, what it runs on the server is effectively just the regular Solr install script, passing these parameters through to it. So we get some dependencies, and we get the official Solr install to install Solr on the machine. So when I deployed it the first time after I had everything working, you can see that it took 1 hour and 45 minutes. So there will be no demo of that. And what happened is I'm running Docker Mac on the beta, or Docker beta on the Mac. I had increased the memory to 8 gigabytes, and the build took, I think, around an hour in that Docker container. And then a Docker update happened, and it set it back to 2 gigs right before I ran this. So if you run it and allocate like 8 gigs of RAM to Docker, it might finish in an hour. That's just a little disclaimer, a quirk I noticed with Docker for the Mac. But you can see, I hope, that there's a last successful artifacts, which is the tarball that I built that I can download. And when it's running, after it deploys to stage, I can bring it up on port 8983 on my machine, and you'll see 6.1.0-1, which is the build number that I had from my Jenkins build. I should note, too, that while Vagrant is configured and I deployed a port 8983 on both the stage and the prod boxes, when I map them to the host, I map prod to 8984 so that I can just use them both from localhost. So now let's talk about, we've got Solr on our target servers. Let's talk about the configuration and what types of artifacts you might want to put in version control. This is the list that I came up with, but you're welcome to put anything else that you might need to change or configure between environments, but any collections that you have, any core properties that you want to set. And I'm going to talk about how to handle different environments in just a second. Your config sets. Like I said, I'm still in a replication deployment, but I am using config sets, which makes it a little bit easier to share configuration between collections that use the same configuration. I would recommend that even if you're not in Solr Cloud, because if you want to move to Solr Cloud, then you have your config sets and your build pipeline could shoot them right into Zookeeper. Any extra Java libraries that you want to include or have available when your core startup, your solr.xml file if you've done any configuration of that, and the Solr, all the defaults for Solr, solr.in.sh. And this is kind of what my repository looks like. You notice I have a home folder directory, which is kind of indicating that this is going to be solr.home when it gets deployed onto the server and whatever instance I've got. Then I've got a subfolder for collections, and anything that I put under there is going to become a collection on the box as long as you've got a core.properties file. I have all my config sets defined. Those are referenced by the core.properties for each of the configs. And then there's a config props directory. I'll show you that in a second. But instead of redefining properties for each core, I reference a core.properties file, which is a directory hire so that I can share the things I want to share. And another thing worth noting is notice the solr.in.sh has a production and a stage version. And that's how, in this example, I'm handling different environmental configs. More on that in a second, right now. So in this example, I use different files for different environments. As you saw, I had one called .tier, .whatever. And then the build script takes, because one of the parameters to it was what environment I'm deploying to, it makes sure that the correct environmental config file gets copied onto the target server. And this is very similar to databags in Chef, or Puppet has a concept called Hiera, which is like a key value store in configuration files. And like I said, I didn't want to include one of those technologies in this just because that would be yet another thing you'd have to understand in order to kind of ingest this. But in many cases, those would be preferable because both of those support protecting secrets. Chef has the concept of encrypted databags, and Puppet has a plugin for Hiera called Hiera eYAML, where if you had usernames and passwords or keys that were stored in your configuration in any spot, you can make sure that those were not in clear text in your version control system. I have a bit of a security background, so I've yelled at a number of people for that in my career. So here's another example with the config props. You can see I have an allcores.properties and a production.properties and a stage.properties. And as for the example, I have brought in 3 collections from the Solr examples. I brought in the data-based data import handler collection. And if you dig into the example, you'll see that I'm selecting, that thing comes with a HyperSQL database file, and I'm selecting a different path for each of the environments. It would be the equivalent of my local development versus my stage versus my production database. I also have the schema list collection and the tech products collection. So this is what it looks like if you're used to using core variables. I hope that's legible. The path to the database file in the data import configuration is replaced with a variable, and that's pulled in from my environmental config allcores.properties. And then once I've deployed my configuration onto my target server, I can run Solr and see all of the collections and run the data import. So some companies might have a requirement for manual intervention during a build process. If you have some key developer or operations personnel or management that must approve releases, there's a lot of stuff you can do in the Jenkins file that I'm not covering, but I thought this was an important one. You can insert a Groovy statement into your pipeline so that it will pause the pipeline until somebody manually goes in and does something like checks a box. And that Groovy statement looks something like this. You can give it a message, you can label the OK button, and then you can also lock down which user or which role is allowed to do that. So in this case, you have to be admin, the admin user, in order to submit that box. If you are connected to LDAP, that could also be a role name as far as I know, but I have not tested that. And when you do that, this is what happens. So the pipeline will stop at a specific spot, and then somebody will have to go to it and actually click approve. And you might ask, well, how do they know they have to go click approve? And what you would do is probably put an email statement before that, because you can send mail with that Groovy syntax as well. And there's other things you could do in order to notify somebody that they have some action that they have to perform. So making this very easy for the search engineers or developers to work with was important to me, because at my company, we've tried to get rid of the idea of a development tier in the server space, and development happens on everybody's local machine. So how does a developer work? Well, what they have to do is they clone and build the Lucene Solr repo, so they've got Solr compiled on their machine. Just run ant server. And then if they clone the configuration repo, it includes scripts to start and stop Solr. And all these things do is run based off of where the Lucene Solr repository is. It will run the bin/Solr start and stop commands, passing a flag to use the home directory in the configuration repo as the Solr home. So they can develop their configuration, start Solr, it'll be running on their machine, and then they can stop it and test things. And you get rid of a bunch of development servers. So I want to do a quick demo here of deploying the Solr configuration, since I have time for that. And if wireless behaves, it looks like it will. I'm going to try to mirror. Oh, yeah, you can see that. So if I start everything with that start script, it's going to run Vagrant up, which is going to bring up those 2 Solr nodes. And then it's going to run the Docker container. And at some point, it will tell me that Jenkins is fully up and deployed. While that's happening, I'm going to bounce over to my Solr configuration and show you one thing that I've changed in the solr.in.sh was that each environment has a different amount of heap size set. So local development has 512 meg set. Stage, I've got 768 meg and 1.25 or so gigs for production. And I'm going to show you that that's what it is and then change it and deploy it. Should be pretty close. Here's my Jenkins on localhost 8080. Admin. And I have some tests in here. I also have the Solr pipeline and the Solr configuration pipeline. Since I've already built this, you can see Solr running on 8983, which is my 768K stage environment, or 768 meg stage environment. And 8984 is my 1.25 gig environment. And the configuration pipeline shows me all of the previous builds that I've done. I had a great screenshot from very early in the development where I had all red, and then at one point I got the next stage was red instead of the first stage, and I thought that was progress. But to give you an example of a developer workflow, I'm not going to start it as developer, but I'm just going to set the production configuration back to 1 gig. I'm going to push this onto GitHub. And now at this point, if your Git server could talk to your Jenkins server, you could have it trigger the build automatically. And that's how I've got it set up internally. Since this is not connected, there's also an option of having Jenkins poll GitHub for changes. I don't have either of those configured right now, but you could do that if you want. So I'm just going to hit build now to build the pipeline. Might have refreshed on me. Build. So what it's going to do is clone from GitHub. We should start to see progress at some point. But this page has been a little touchy with refreshing properly. My tests are also very simple. Right now they're just doing a curl of the port for the expected environment. I think this takes about a minute to run. While that's going, put that back up, get that ready. Did I miss it? There. So if you dive into that build, you can also watch the output as it's logging things and see it all happen. Any questions while this is going? Just waiting to see wireless drop and the whole thing fail, right? It's the curse of the live demo. I had a lot of trouble with my phone on the wireless here. All right, stage is deployed, so if I go refresh this, I haven't made any changes to the stage environment, but it is still running. It did take a start and stop. And something else worth noting is if you're in Solr Cloud, you can upload your configuration into Zookeeper and then do rolling core reloads or whatever you need to do in order to restart each server. I'm deploying, like I said, to 3 different servers, so effectively I just have a bash loop in my deploy script, that hits each of those servers with whatever the environment is. All right, that's done. So now I'm proud if I refresh, it should see 1 gig or pretty close. So the memory changed. Fantastic, awesome. Not that I wasn't confident, but. So let me put this back up if anybody wants to take a screenshot. I have the link to my repositories. There's a link to Jenkins pipeline description, which explains all the other things you can do in your pipeline, including like running stuff in parallel and forking your build pipeline. There's a link to a Martin Fowler talk on continuous delivery, and it's a really good one if you want to learn a lot more about the history of that. I respect Martin Fowler a lot, and my Twitter's there. And at this time, I will take any other questions. We have 10 or so minutes remaining. All right, well, if you think of anything, you can come find me at the conference. I'll be here through tomorrow. Thank you.